The time has finally come. In this lesson, we're going to take what we learned in our previous video and we're going to start factoring using a GCF. Are you ready? Let's go. All right, in order to factor using the GCF, you should already know how to find the prime factorization of algebraic expressions and the GCF of algebraic expressions. You also need to know how to find the quotients of monomials. So if you don't know how to simplify that expression, 6xy to the third over 2xy, you're going to need to go back and do a little bit of review. Let's get started. All right, so factoring is basically reverse distribution, and we can use it to write a sum or a difference as a set of products. Factor 5x squared plus 10x. First, we find our greatest common factor between the terms. Now, keep in mind you may have 2 terms, 5 terms, 10 terms. Every time you factor, you start with your GCF. In this case, our GCF is 5x. So I'm going to set it outside of a set of parentheses and divide each term by the greatest common factor. Now, do you see what we're doing here? By multiplying by 5x on the outside of the parentheses and dividing by 5x inside of the parentheses, we are essentially multiplying our entire expression by 1, which means we're not changing the expression, we're just changing how it looks, which is key to factoring. So then we simplify the expression inside the parentheses, get x plus 2, and our final answer is 5x times x plus 2. Let's try another. You can do this one on your own. Try to remember the steps from the previous example, pause and restart when you're ready to check your work. I'm going to get started. First, I need my GCF. In this case, it's 3r. So I'm going to take 3r and place it outside the parentheses and divide each term by 3r. I simplify inside of my parentheses, and I get 2r squared s minus 6r s squared plus 1. And we have our final factored answer, which we can box and move on. Third example, 3x to the fourth y squared plus 15x cubed y cubed. Pause and restart. Our greatest common factor is 3x cubed y squared. Place it outside my parentheses and divide each term by 3x cubed y squared. Then simplify your answer in your parentheses to get x plus 5y. Finally, our factored form is 3x cubed y squared times x plus 5y. And we're finished. This example is a little different, but it has the same idea. Remember, we always start by identifying our greatest common factor. In this case, it's a binomial. Can you see it? Excellent. The greatest common factor is x minus y. So we're going to bring that outside of our parentheses, and then we do the same thing. We divide every term by x minus y. We simplify, and we're left with x plus 3y inside of our parentheses. Our final factored form is x minus y times 11 minus 3y. Our final example, and I made it a little tricky. Do you see a greatest common factor? Not quite there, but it's close. A minus 3 and 3 minus a are opposites, so we can actually bring a negative sign out in front and switch the order of our terms. That gives us a positive sign between the two terms. There we go. Our greatest common factor is a minus 3. That is beautiful. Wow, chef's kiss. Now, we're just going to do what we did before. We're going to bring our GCF outside, and then we're going to divide each term by a greatest common factor, which is a minus 3. We simplify inside the parentheses, and we're left with 5 plus 2a. Our final form is a minus 3 times 5 plus 2a. Box that, and we're finished. Okay, we have started our first steps in factoring polynomials. We take out our greatest common factor. To do that, we find all shared factors, take the lowest power of each, divide your expression inside the parentheses by the GCF, and simplify. Now, we always begin factoring by looking for the greatest common factor, so make sure that you feel comfortable with this skill. This is the leftmost of our factor tree, and over the next few lessons, we'll fill out the rest of our tree, and once we have our methods together, we're going to review how to choose between them. Our next lesson is the difference of squares, and I will see you then.